So now let us discuss about how do we convert regular expression into a finite automata. So basically there are two approaches. One is direct and another one is indirect. First let us see the direct approach. For example, if they gave regular expression as A, first we have to draw the initial state, then the final state. They gave A, right? Just keep the transition as A. Next, if they give A plus B, remember, whenever they give plus, it means that we give two separate input alphabets but to the same state. Plus means it goes to the same states, but multiplication means we need an intermediary state. See, Q0 goes to Q1 on A, Q1 goes to Q2 on B. So now this Q2 is gonna be the final state. Okay? And now if the regular expression is A star, then it means that we have more number of occurrences of A including epsilon. So what we do is we keep a self loop. That's it. What if it's a null transition? We don't have to keep any transition in between. We'll just draw initial state and then the final state. Okay, now let us look at the indirect approach. So in this, have a look at it. Regular expression is A. So we have to make sure that before and after the input alphabet, we need to have epsilons. In direct approach, for one input alphabet, we only had two states. But here for one input alphabet, we had four states. See, Q0 to Q1 epsilon, Q1 to Q2 A, Q2 to Q3 epsilon. Okay. For regular expression is equals to A plus B, I already told you, if it's plus, it goes to the same state, right? So Q0 epsilon Q1, A Q2, epsilon Q3. A is in between two epsilons. Now we have to make sure that B also reaches Q3. So epsilon B, epsilon. Okay. Now next is AB. If it is AB, then it goes to a different state, right? Epsilon A, epsilon B, epsilon. This B is also in between two epsilons. A is also in between two epsilons. So we took 6 states over here for two input alphabets. If it is A star, what did I say? It means it has multiple occurrences of A, right? And it has to be in between epsilons for indirect approach. So we will make sure that first we'll just draw the A directly. Epsilon A, epsilon. Then we'll keep two loops. Epsilon and epsilon. So basically these are the basics, okay? This direct approach and this indirect approach are the basics. Now let us look at an example. Okay, now this is the given question. AB plus BAA into BA star A. This is the given regular expression and we have to solve it using direct approach. So the step 1, consider the whole regular expression as a single input alphabet. So what do we write it as? Q0 on A goes to Q1 plus A, right? So we'll write the whole expression over here. Now let us look at it. This looks in the form of A plus B. If it is A plus B, then how do we write it as? It goes to the same state but in different paths. So AB over here, B plus AA into B star A. That is over here. Okay. Next. Now what do we have here? We have AB over here. What do we do when we have AB? We put an intermediary state, right? So Q0 on A goes to Q1, Q1 on B goes to Q2. This is as it is. Now this is also in the form of A into B, right? So now let us further divide it. It is the same over here, and here B plus AA, intermediary state, B into A. Okay. Now let us divide this further. It looks in the form of A plus B. So we'll be having one path like this and one path like this. So B over here, AA over here. Now we have B asterisk A or B star A. What did I say? If we have B star or A star, we have to use in self loop. So this B star will be turned as in self loop on Q3 state. Okay, here we have B. Next, do we have anything further like to reduce? We have AA over here, which we got here. AA is in the form of A into B. What do we have to do if we have A into B? We have A, intermediary state, and Q3. A and A. Now we'll be drawing the transition table for this particular diagram. Q0, Q1, Q2, Q3, Q4, A and B. So Q0 on A goes to Q1 and also Q4. Q0 on B goes to Q3. Q1 on A, nothing. Q1 on B goes to Q2. Q2 on A, Q2 on B, it goes to nothing. So we'll keep it as phi or hyphen. Next, Q3 on A goes to Q2. Q3 on B goes to Q3 itself. Q4 on A goes to Q3 and Q4 on B, there is nothing. This is NFA, right? How do I say that it is an NFA? We already discussed in the types of finite automata that if one particular state goes to two different states using the same input alphabet, then it is known as NFA, right? Okay, now let us convert that NFA into DFA. How do we do it? First we'll copy as it is, like Q0 to Q4. We'll write everything as it is. Now we have Q1, Q4, right? We have to consider this as a single state so that we can consider it as a DFA. Because if Q0 goes to a Q1, Q4, which is a single state, then there is nothing wrong with it to be a DFA. So Q1 and Q4, we take it as another state. Now look at this table. Q1 and Q4 on A goes to phi and Q3. Phi union Q3 is Q3. Q1, Q4 on B goes to Q2 and phi. Q2 and phi union is Q2 only. That is what we'll be writing here, Q3 and Q2. And now we'll be drawing the transition table for it, transition diagram for it, like Q1, Q4 as one state, and we'll just draw it. Okay, thank you.